Caxy Interactive, a full-stack digital development company based out of Chicago, Illinois, offers a range of technical services including user experience work, design, development, and consulting. Reliable energy access is not only essential, but also fundamental for developing regions. Caxy Interactive's focus is to provide accessible energy for Central African regions where energy is needed, such as in Cameroon, where less than 27% or 8 million rural Cameroonians have minimal access to energy. To continue accomplishing this mission of theirs, they have employed us, Team Caxy Interactive, to create their remote energy distribution payment platform for their current client, Energy Wells, an energy supply company with the mission to provide clean, affordable energy to sub-Saharan communities. This marketplace application aims to help the people living in rural areas have access to reliable off-grid energy. Our remote energy distribution payment platform offers a lightweight solution for hardware charging stations to support off-grid charging by providing the ability to access, track, and manage energy transactions with SMS in an online interface.
Once a user is signed up, they are able to access the site to add funds. When releasing energy from a B power station, a user will need to preload their account with the necessary funds. Using Central African francs, users can enter a variable amount. Accessing a payment portal, users can upload a balance with just a few clicks. From there, a user can now access any B power charging station with just a text message from their phone. So let's take a look at how transactions work up close. When a user starts a transaction, they're first going to be prompted to enter a 5-digit randomized code into their SMS application. From there, the server is going to render them a message asking how many francs they would like to spend. In this case, we're just going to spend 3. So once that happens, we're going to also be asked for the voltage setting, which in this case there are 3 options. We're going to choose 6 volt for charging our toaster. Finally, we're going to get a release code. So what the users are going to do is they're going to enter this into the B power station. Now this code contains 3 pieces of information. It contains the kilowatt hour cost provided by the server, the total amount of francs the user is willing to spend, and then finally the voltage setting that they are trying to use. So once this is done, the station will start to charge. Here we are going to see that it will charge to 3 francs before providing a release code. Now once this release code is given back to us, this is going to provide the server how many watts was used by the person and kilowatt hour cost. Now this receipt will finalize the transaction and provide the server with the necessary information to charge the user and continue on for another transaction.
Wahoo!
So we saw a pile up at one of our stations. Now as an admin, we have access to analytics with in-depth views of how our stations are actually doing. So on the transaction tab, we can see here we have a chart with information provided to us about the charge station, the amount, and also the energy used at each station. With some filters to use, we can select a date from, and we'll see here that again, Aqua has been used quite frequently. We can also apply filters to the stations themselves. So we see we have some in our chart still, so let's go ahead and filter that down. Once we do that, we can take a really in-depth look at how Aqua is doing. Seeing that this is a potential issue, we can begin to start thinking about how we can remedy this. With managed stations, we can see all the stations that are accessible via our system. We see here that we have an East Lansing station named Aqua, and we can go ahead now and try to create a new one. So with that, we can now add a phone number to this associated station. We can also add a name, price, and location. Now when adding these into our system, the station will still need to be set up as we will see in a moment, but we'll name this one Maroon and give it a price of $50, which is the same price as our East Lansing one. So once we do that, we can hit create, and if we go back, we will see that we have 2 East Lansing stations available. After receiving a quote about the cost of this station, it turns out Maroon will be a bit more expensive than expected. As an admin, the station's price can be changed to reflect any of those changes in cost or conditions that are not currently present. Now let's head over to Maroon and check how construction's going. Here we have a user trying to charge a device. When texting the B-Power charging number, he found out that his account does not have enough funds. However, even without an internet connection, this user will be able to call the number provided and begin adding funds through a phone call. Now let's see how that works.
Welcome to Energy Wells charging station. Press 1 to add funds and press 2 to check the balance on your account. How much funds would you like to add to your account?
Here the user will provide a few pieces of information to complete the transaction. The call will prompt the user for a balance to add, a confirmation of the transaction balance, and finally the credit card information in order to process the payment. Once this is completed, the user will receive a confirmation and the call will end. Now let's get back to charging.
Thank you for your payment. Your account now has a balance of 1151.2 CFCA.
Our application primarily interfaces with the user's mobile device and Arduino hardware station. Users will also access a web application that hosts the account with the user's funds for releasing energy. The web app is hosted with the cloud platform Heroku, while the server was built off Express.js. Transactions, user balances, and payment history are all stored in MongoDB, a NoSQL database solution. Mobile devices connect with Twilio, a communication tool used to communicate with the user by both text and call. Stripe supports payments for both the web application and voice call. The web application views are rendered with an HTML preprocessor PUG. User management, which includes creating accounts and logging in, as well as role and account-based views, is handled by Google's Firebase. Now let's take a closer look at how SMS works for the user.
Text messaging can be described as a single transaction document in our system. There are 4 primary stages to identify where a user is at in their transaction. Based on the stage, a different prompt will be provided to a user. The first stage is when a user initially texts the server the 5-digit randomized code from the Arduino. The second stage requests the user to enter a valid balance. In the case it's invalid, the user will respond with either a request to add more funds or enter a valid amount. Once the amount is valid, the user can continue. In the next stage, the user enters the voltage setting. Once this stage is completed, the release code for a charging station is provided. The final stage occurs when the user enters the receipt code provided from the Arduino. At this point, the transaction will be complete and the document tracking this interaction will be stored away.
We'd like to thank Michael from Caxy Interactive and Dave from Energy Wells for providing us the necessary support and assistance when developing this project. We'd also like to thank Dr. Wayne Dykeson and Dave for providing us with access to the necessary hardware to ensure the project's success. And we'd like to thank the rest of the CSE 498 staff for aiding in a timely, deliverable, and successful project.